Okay, can everybody hear me? Just a little bit more background so you know a little bit about who I am. I've been growing produce for about 31 years. I've been helping other growers with their soil fertility for about 15. And I'm married to my wife Lisa for 32 years. And I have 8 children. 4 are biological and 4 are adopted. And I now am I have 3 grandchildren that call me Gramps. So we will go. We were supposed to start at 3. I've got about 4 hours worth of material that I thought I was going to fit into 2.5 hours.
Stop at 6.
So we'll get as far as we can, and I may skip some stuff just to try to get to the most important things. We may need to leave out some of the details, but I'm just going to set my alarm.
Breaking point, Whitmar, we could actually go till 6 o'clock because I know you lost 20 minutes.
Okay. We will go. Oops, sorry, wrong thing. We will go till 4:15, if that's okay with everybody. And then, no, you know what? I'll just leave this up here because I don't want to interrupt it with that. Okay, so let's just start with this slide. This top quote is a quote from Linnie Marsh Wolf. I don't know who Linnie Marsh Wolf is. It's actually a quote, an interpretation of a quote that John Muir, the naturalist, spoke, which was, when you tug on one thing in nature, you find it's connected to everything else. Has anybody experienced that? If you haven't, you will. Now, I use this quote, and I'll read it here. Everything is so inseparably united, as soon as one begins to describe a flower, or a tree, or a storm, or a chipmunk, up jumps the whole heavens and earth and God himself in one inseparable glory. Now, I use this quote because you could interpret that 2 different ways. You could interpret it as, well, God is in everything, right? Or you could interpret it as the whole of nature testifies to the glory of God as creator. That's the way I take it. So I want you to be sure to understand that that's the way that I take it. And so I put another quote up there, Job 12:8, which it's only part of the verse. Speak to the earth and let it teach you. So we're going to go, what I'm going to share with you, we're going to start off here with principles of soil fertility. Because if you don't get these principles right, you'll be led down every path you can imagine into a dead end. And the Bible says that there is a way that seems right to a man whose ends lead only unto death. And I guarantee you there's all kinds of paths you can go on. And most of them are popular, very popular, to go down. So we're going to look at it from a perspective of God as creator. And I'm leaving out some material here because we just don't have the time. But everything that I'm going to talk to you about is demonstrable. It can be demonstrated. It can be observed, and it can be repeated. And if it can't do those things, then it's just speculation. And there's a lot of things out there that are claimed to be true, but you'll discover as you engage in them that they're really not true. So, does anybody know what that's an image of? I heard somebody say it. Photosynthesis. Separate from the breath of life that God breathed into our nostrils, all of life depends on that. All of life, including you and me. And sometimes we forget that God created a physical world, and we're going to look at here in just a second, that we were given dominion. over that world. And unfortunately, we've kind of messed it up quite a bit. But all of creation is dependent on photosynthesis. And we're going to look at the different aspects of photosynthesis and what's required for that to actually happen. And you see in the diagram here, there's sunshine. So energy comes from the sun. It has to be captured by the plant. In order for the plant to capture that, it has to have carbon dioxide and it has to have water to do that, to actually produce sugar. This is the chemical equation for the photosynthetic process. It takes carbon dioxide and water, and with chlorophyll and sunlight, and it's actually more than chlorophyll, we'll see in a few minutes here, you get C6H12O6. Anybody know what that is? Glucose, sugar. What else is it? It's energy. Without energy, nothing happens. Now, going back to this, what all's involved in order for that to happen? What is required for that plant to grow? What's required for you to build a house? Materials. Or to build a car, or a bicycle, or whatever it might be. There are components necessary to build that plant. And then there's machinery that's necessary to be built so it functions to actually run this whole process. Now I was going to put the chemical makeup of chlorophyll. Chlorophyll has hundreds of just carbon atoms in it. Just a chlorophyll molecule has hundreds and hundreds of carbon atoms in it. It has a whole bunch of hydrogen atoms, has a whole bunch of oxygen atoms, and then it has some other stuff. And that's what we're going to look at, because without it, this equation never happens. Now, a lot of you, well, let's go through this other stuff first here. A recent survey of life on Earth measured in gigatons of carbon estimated there are 550 gigatons of carbon-based life forms. A gigaton is a billion tons. 550 gigatons. 450 gigatons of the 550 gigatons are in plants. So the largest share are in plants. Trees, grass, you can go down the list. 93% of the remaining 100 gigatons are microbes. 4 gigatons of protists or protozoa, 7 gigatons of archaea, 12 gigatons of fungi, and 70 gigatons of bacteria. So that of the 100 gigatons left, 93 gigatons is in microbes. Of the last 7%, humans comprise 0.01% by weight of the biomass on Earth. You sound very significant. Well, I already said that we have to decide, are we in competition with that or in cooperation with it? Did God give us dominion or did he not give us dominion? This is what he gave us dominion over. And quite often we don't take into consideration what he gave us dominion over. And if we had the time and opportunity, I do 2-week presentations on this material. And so if we had the opportunity to go into the detail on these things, you would see why the Bible says that the earth is groaning under the curse. You would understand why it's waxing old like a garment. Is there nothing we can do about that, though? In Matthew 5:45 it says, "For he causes his sun to rise on the evil and the good, and sends rain on the righteous and the unrighteous." God does not withhold his blessings from anyone. We block his blessings from being received. There are barriers created that prevent the blessings of God from being received. But he doesn't withhold them. And we need to figure out what those obstacles are so that we can move them out of the way. We're going to be looking at just principles here. We're not going to get into any of the real chemistry. We're not going to get into the biology, other external influences here. Before I go any further, let me just point out, we're going to talk about soil fertility here. Well, we're actually going to talk about both. We're going to talk about the soil. And the whole time that I'm talking about the soil, I want you to think about your character. And I want you to think about your own heart. Because one of the things that when you go out to farm, or you go out to your garden to grow and everything, does anybody have any problems? Everything just no problem, no diseases, no insects, no weeds choking everything out. Wrong planet, yeah. Okay, one of the things you need to know, we spend most of our time fighting off death rather than fostering life. Don't we? So if we have some sin that keeps harassing us and hounding us and we just gives us a hard time all the time and everything, we fight it. But we don't foster what would remove it. And you'll see as we go along, those diseases and those insects and that weed pressure, you don't have to fight that. What you have to do is foster the life in that soil. And guess what will happen? Those pressures will go away. Now, does that sound outrageous to you? I could share experiences with you of anywhere from little gardens all the way up to 10,000 acre farms who have removed those pressures in their system. They're messengers, and we'll get to that in a minute. Has anybody heard of Louis Pasteur? What did he discover? Yeah, he discovered penicillin, but he's the one that established what we call the germ theory. That germs cause disease. Have you heard of Antoine Beauchamp? Anybody? You have heard of him? Okay, good. Antoine Beauchamp was a contemporary of Louis Pasteur's, and his contention was that it was not about the presence of the germ, it was all about the terrain. And what did he mean by that? There are fields that will have exactly the same amount of what we call a disease organism in them, and one crop will succumb to that disease and the other field won't. It's all about the host, not about the pathogen. And we focus our energy constantly on fighting the pathogen rather than strengthening the host. And unfortunately, quite often, most of the time what we do, we actually weaken the host and we strengthen the pathogen in the process. Unfortunately, Beauchamp was obscured in history because Pasteur got all, once he discovered that, all of the money, all of the attention and everything went to Pasteur. And so now we focus on the germ. We focus on the pathogen. Now, there really are germs. There really are pathogens. But I just want to add here, in case I don't add it later, God gave a food source to every single organism, every single creature in his creation. He provided for every single one of them. What happens when that food source is taken away? Well, it could potentially die, but in general what happens, it resorts to an alternative food source. You want to hear a gross illustration? Has anybody heard of the kiwi bird? It's the national bird of the country of New Zealand. Well, there's a particular tree that those birds, that's their primary food source, is the roots of that tree. Now, they don't kill the tree. It actually stimulates the tree to grow more, but the primary food source is that tree. And in the development there in New Zealand, just like everywhere in the first world, they started taking and cutting down a lot of those trees to build houses and shopping centers, et cetera, et cetera, et cetera. So they were taking the food source of this bird away. Now it's the national bird of the country. Guess what they chose as a food source instead? Yeah, sheep. In particular, the kidneys of sheep. They would hop on the back of the sheep and peck into their kidneys and eat their kidneys and kill the sheep. Who said sheep? Cool. So they discovered that the reason was because their main food source had been largely removed. So they immediately went into a project of replanting these trees and everything like that. And once they got a lot of these trees established again, guess what the kiwi bird did? It went back to eating the roots, left the sheep alone. Now, we could go through dozens of illustrations on this, and I'm sharing this illustration because what we call pathogens or disease organisms, for example, in the soil, or pest insects that might eat on your plants, they're choosing an alternative food source. And we'll get to that hopefully when we get to carbon fertility. You'll see that the plant is supposed to be giving to these organisms. It's supposed to be supplying the food source to them. And when it does, these what we call pathogens become benign. They actually become probiotic and supportive and helpful to the plant. Does that sound strange? It's an incredible thing to see when it happens. Seeds want to grow. Now, I work with people all over the world. I see soils everywhere. There's about 125 billion acres, I think, worldwide that produce of agricultural soil. Produces about 5 billion tons of food. And the majority of people in the world eat, or at least hope to eat on a daily basis. And yet, the health condition of society is deteriorating every day. So I'll have people say to me, well, I planted stuff, it came up, it grew. I had to use some pesticides on it, fungicides possibly, could be a variety of things. But I got good produce out of it. And I'm sure they did. Just having something fresh makes it superior to anything you could buy in the grocery store. Because just in the process of shipment, the time frame taken from harvest to shipment and to the market, and by the time you get it home to prepare it, it's anywhere from 10 days to 2 weeks old, and it's lost up to 50% of its nutritional value on it. So just having it fresh can be really good. But my question is, are we producing food that's medicine? And your food should be your medicine. Your food should keep you healthy and protected from anything from around you. Now, I'll use another illustration here just because we need to look at two different aspects of it. What if you're doing everything for your soil, things are growing really well, your crop's growing and everything, and a hailstorm comes through? I know from experience. And shreds your crop. Did that have anything to do with all the right things you did? No. See, we live in a world with 8 billion other people who don't necessarily, including ourselves, don't always necessarily make good choices or right choices. And unfortunately, that pool of effects sometimes reaches us. And so that's the other part of a soil, of your gardening or your growing system, is you've got environmental influences, which we're going to look at. You have your soil, which you have the most control over, and then you have these environmental influences that you can sometimes modify, you can sometimes mitigate some of the potential impact. But I know, like I said, from experience, that we did everything right. Hailstorm came along and took it all out for the season. That was it. What do? All right, we'll skip that slide. But my point is, I'll just tell another illustration here. When I was living with my sister for a little while after I finished school, and I learned about this method called the double digging method. Has anybody heard of the double digging method from John Jevons? And I was all excited about it and everything. So I went out and took a piece of the ground where she lived, and I double dug that ground and got it all prepared. And it was up higher by that much because I loosened it all up and everything. And I planted some melons out there because I love growing melons. And my sister came out of the house. She wanted to plant some flowers by the back door. So she came out of the house with a spoon and dug a hole just big enough to get the seeds in. And put the seeds in and planted them. What do you think happened with the two different places? Well, the mice came and ate all my melon seeds. So nothing came up there. And her flower seeds came up. And they grew. Now, they weren't as big and beautiful as they could have been, but they came up and grew. So things will grow because they want to grow. God mandated to be fruitful and multiply. And so that seed, from the time that it goes into the soil, is going to target being fruitful, bearing good fruit. Now you'll see that sometimes that causes the plant to do itself in. But we'll look at that a little bit. Okay, so you guys have all heard of organic growing, right? So I put the question in here because people get very confused about what's what. What is organic growth? And I put under there a phrase that Dr. Carrie Reams used to always use, see what you look at. So is that organic growth? I heard a yes. Any no's? Don't know? That's organic growth. That's organic growth, whatever's growing. That's the extent that life can grow there. This is that same valley. Is that organic growth? No. Why not? Somebody intervened here, didn't they? That's what it is. An entire valley is seedless grapes. Is that organic growth? This is a tricky one. This is in New Zealand, which they call God's country. I'll tell you an interesting story about this. This is not organic growth. And you can't even see why it's not organic growth. When they first came to the islands, Australia, but New Zealand in particular, all the pictures of New Zealand you've seen are all these green, lush fields, right? And they thought, well, this is a great environment to raise livestock. So they brought a bunch of livestock there. And the livestock ate and died. And like I said, you can't see why. But it's because there's just a lack of about 2 pounds in a 2 million pound plow layer, about 2 pounds of cobalt. There's no cobalt in this soil, naturally. They figured that one out, and they applied cobalt to these fields, and now they can raise livestock. You know what cobalt is the center atom of? Vitamin B12. Cyanocobalamin. I usually spend some time talking about that. We don't have the time to talk about that. But you can't see in this picture. That's such a small thing. And I put that in here because I want you to understand that a lot of times as people, we have all kinds of ways of glossing over and making ourselves look better than we really are. When in reality, there's a whole lot of little things that are not going right. And until those little things are corrected, you're not going to thrive. You're not going to produce food as medicine. And I don't share that to make anybody feel bad. But what will happen with nature when you actually go out to garden? Nature is going to call it exactly the way it is. And that's why so many people don't like doing it. Because you keep coming up against, I've been doing this for 31 years. Somebody asked me to set up a 2-year college program in agriculture, and I just asked, why 2 years? And they said, oh, well, we wanted the students to be able to see a couple of seasons. At that point, it was 25 years for me, and I said, well, I've been doing this for 25 years, and I haven't seen the same season yet. Anyway, let's keep going here. Is that organic growth? You'll get it by the time we get through these. That's not organic growth. Why is it not organic growth? Did that just happen there by itself? No. What about that? No. That? What about that? I told you we were given dominion over the earth. And God wants to restore life. He wants to restore our lives in every way possible. Not just spiritually, but physically, emotionally, mentally, socially, everything. But there's a way to do that. So the question is, I put here intervention, imposed or imparted. Quite often we like to go out and impose ourselves on a system. This is what I want to happen here, and it should work because that's what I want to happen. Rather than asking the question, what should happen? What are the conditions that would allow things to grow and thrive here? And then imparting those to it. So is there an ideal or a model soil? When God told Noah to build an ark, did he hand Noah a catalog of boats and ask him to pick the one he thought he would like the most? What did he tell him? Build it exactly the way I tell you to do it. What about the ark? The sanctuary. When God said to build a sanctuary, did he give Moses a catalog of houses, buildings? No. What did he tell him to do? Follow the pattern. Do you think there's a pattern in nature? Or when God created man in the beginning, did he take that dust, just randomly throw it into the air and breathe on it, and it became a living being? Or was there a deliberate design to it? Everything God does is specific. Everything he does is deliberate. It's not random. It's not generalized. It's all specific. And so the question is, if there is an ideal or model soil, what is it? Do we have any way to figure it out? This is a pie chart of what is universally considered an ideal soil. Nobody contends that this is not an ideal soil. Universally agreed that this is an ideal soil. That soil is going to contain about 45% mineral, or dirt we would call it. And the other 5% would be organic matter. That would be roots, humus, which is organic materials, organisms and roots that were once alive, died, and organisms will make up about that 5%, and that's about half the volume of the soil. The other half is airspace, pore space we call it. And of that half of that half would be filled with water. That's an ideal soil. So I'm done. You guys can go out and come up with an ideal soil. Is there anything missing, any details missing from this? What minerals? Yeah, how do you get there? How do you get to half of that space as pore space and half of it's solid? How do you get so that half of that pore space is filled with water and the other half is filled with air? So there's a little more detail to it. Well, this is where people diverge from the ideal soil and how they think that you achieve the ideal soil. And so we're going to look at those. There are different schools of thought. First one is the conventional school of thought, and that's largely the dominant school of thought. Most agriculture is operated under these premises, especially in the West. You have some third world countries who think that they want to do that, but they don't have the ability to do it under the circumstances. But there's what's used is selective chemistry, and we're gonna look at that in a couple of slides. what that achieves. Does anybody grow for profit, crops for profit in here? Are y'all primarily just gardeners? Okay. I've grown for profit for 31 years, and I can tell you that farmers don't get paid for quality. They get paid for quantity. So, by the hundredweight, by volume, bushel, bin, it's all volume. And what is that volume made up of primarily? Yeah, water and calories. Energy. Lots of energy. We have a problem, a health problem in society, particularly in the West, that's related to this. Because you've got a lot of calories and no minerals, or inadequate minerals. Now, the plant grew, and because people will point out, well, the plant grew. Well, yeah, it can grow. One of the things, when they measure the quality of a crop, like for livestock, now it's interesting the stuff they'll focus on livestock, but they won't really focus on people, which is interesting. But for livestock, they'll usually measure like the grain or the hay, the forage that they're feeding them. Sorry about that. To see how much protein is in it. But they use a measure which simply measures the amount of nitrogen in it. And then they extrapolate that with a factor which is 6.25, and that tells them how much protein is in it. Well, they've discovered recently that just because the nitrogen is there, it doesn't mean that the protein is there. And it also doesn't, the protein might be there, but the protein is not built right. Anybody heard of autoimmune diseases and allergies? That comes from food sources that are not built right. And your body, when you consume it, look at it and say, this is foreign material, and it doesn't belong here. So they've been doing that for decades, just assuming that the protein was all high-quality protein, that it was useful protein, when in reality it wasn't. But that's the vast majority of the food that you can buy in the grocery store is volume. It's just calories. And we're going to talk about that a little bit more as we go along here. The next school of thought is the organic school of thought, and it's primarily focused on farm-generated mediation. In other words, growing cover crops, putting the manure back from livestock. But the materials are generated from the farm. Now, there's some valuable principles that are involved in that, but they ignore looking at actual chemistry. By and large, now I shouldn't say universally, but by and large, chemistry is not focused on. And hopefully we get to it, you'll discover that chemistry is foundational. Just when I say chemistry, you just think character. And if you don't get that character right, there's a lot of things that go wrong. But you have that school of thought. Oops, sorry. The next one is the biodynamic school of thought, which is, somebody invariably will say, well, you didn't quite define that correctly, and I admit this might not be an exhaustive definition of each of these. I'm just trying to give you some general ideas of it. A holistic, esoteric mediation. And so there's, balancing energies and harmony. I don't know the terms I want to use for it. Now, there's some value in that too. Remember I talked about, everything should have its food source? Well, if you can get harmony and balance in your growing system, but they ignore chemistry too. And there's a reason why I'm sharing these with you. Permaculture is a natural ecosystem mediation where you kind of encourage what nature's doing. But I'll tell you, if you've observed over any period of time, nature's deteriorating. It's declining. It's getting worse. It's not getting better. In fact, you have successions where they'll talk about a grass succession, which is the most fertile, and then it moves to a deciduous forest, which is less fertile, and then it moves to a coniferous forest or pine forest, fir. which is even less fertile. And what nature's doing is actually trying to hold on until help can come. Unfortunately, a lot of the time help doesn't come. I lived in Colorado for 20 years, farmed in Colorado for 20 years, and I experienced the pine blister beetle out there. Has anybody heard of that? That decimated millions of acres of pine trees, because there is a threshold I'll say it now. There's a threshold at which an organic or naturally growing system cannot maintain stability. And I'll just say that here because I didn't say it yet, that organic growth is the highest level of function that the natural system can maintain with stability. But we had slight change in weather patterns, and you have a deterioration of the soil, which happens over time. It's happening right under your feet every single day. And so it just got to the point where the natural system could not maintain stability anymore. And next thing you know, literally hundreds of millions of trees were gone on that. Okay, biological school of thought is microbial mediation. It's the biology takes care of it all, works it all out. But again, if you actually go out and observe nature, they're not doing a very good job if that's the case, because the systems are declining, systems are deteriorating. Without any intervention, they are deteriorating. You have the Albrecht CEC, which stands for cation exchange capacity model, which is mostly what I follow. And it's complete and balanced chemistry mediation. Now, we're going to talk about chemistry, but we're also going to talk about physics, and we're going to talk about biology, because they're all relevant. You can have great chemistry, but if you don't have any life, you're not going to get anywhere. And then the most recent iteration of schools of thought is the regenerative school of thought. And that's, again, microbial mediation, where encouraging the biological communities in the soil will help rebuild the soil and improve it. And again, all of these schools of thought have some truths in them. But what does Satan like to do? Add a few truths with a few what? Or a lot of errors. A lot of lies. And you never really get the right picture from them all. So we're going to look at, I said that I followed that one to the last, but I also practice parts of every single one of these in a proper soil system, in a proper growing system. So let's just look at some of the principles that are involved that you have to address. And I hope, by the way, that if something's not clear to you, please feel free to ask about it. But I always get labeled as an advanced course. But I'm breaking this down to the simplest terms that I can. It's kind of like wrapping your head around anything that you're not familiar with, it's new to you and everything. Sometimes the learning curve is steep, and it takes hearing things over and over. It takes seeing them, working with them to get it to sink in. And like I said, nature will not play games with you. It will tell you, it will function exactly at the level it can function, the highest level it can function. And if it can't function, what do we do, by the way? If you have a lawn, you go out, you till it up because you want to plant a garden. And so you plant your garden. What did you just do? Well, you probably destroyed some microbes in the process, but they'll recover. What you just did is you changed the expectation of that soil, the demand on that soil. And the real question is, can it maintain stability with what you're expecting from it? You just imposed a different condition on it. And can it maintain and provide for you based on what you want from it? And that's when you discover that probably not. And the diseases come in, and the insects come in, and the weeds take over. Now, if you can't do anything at all, remember, well, we'll talk about that when we get along here. Okay, so these are the principles. When you're wanting to grow a garden, you're wanting to grow healthy food, you're wanting it to be productive, you've got to have complete and balanced chemistry. And we don't have complete and balanced chemistry. I've seen soil samples from all over the world, off of every crop you can imagine, out of agroforestry, out of landscaping. And I can assure you, just as the Bible says, there's none righteous. Not one. Not one. And even the best ones still have things that we don't understand very well yet. You know, there are mineral elements that in parts per billion double and triple lifespan in laboratory animals. There are trace elements, that in parts per billion will reduce energy consumption. Or you could put it a different way, will increase energy efficiency 100-fold. And we're just in the infancy of understanding or comprehending all of that, because all of the big stuff has still not been addressed yet. But we do know that complete and balanced chemistry, and we'll look at why it matters. Because you have to build that plant. It has to be able to grow and function. And when you put a seed in the ground, that seed has a little package of nutrition in it. And that's what it starts off on, is that little package of nutrition that's in that seed. And actually, you may not know this, but it actually has a microbial package in it too, of biology, of microbes, not just minerals. Or it's supposed to. I've noticed over the years, and I don't know how avidly you guys garden or whatever, or if you're just here to learn, but that I used to be able to save seed for 5, 6, 7, 8 years. When I buy seed, I could use it for multiple years. Well, that's not the case anymore. Almost all the seed that you buy, you're lucky if you get 2 or 3 years out of it. Sometimes you don't even get 2 years before it's not viable anymore. And there are reasons for that, because the system is degrading everything. Okay, another principle here, living roots in the ground. What do I mean by that? You need something growing on your ground as often as you can possibly have it. Have anybody flown in an airplane over the country, particularly in the wintertime, over the country, and see all these fields that are just bare? You'll see it, 70% of the year, most agricultural soil is bare. Nothing is growing on it. There's reasons when we get to the biological stuff, hopefully if we get to it, why that matters. Because it actually does build the soil. It actually does restore health to the soil by keeping something living there all the time. And the next principle is keep it covered. Now, this can be from living roots. This can be from the crop that you're growing. This can be from a cover crop that you have on there. It can be from a mulch, a hay mulch, a straw mulch, the residues from crops that you're growing that you just mowed down and left there. Why is that? Well, when the ground is bare, it can't maintain temperature as well. It can't maintain moisture. I was just reading some information from a research station in Texas, and they had a cover crop growing there, and then they had area where they didn't have anything growing, where the soil was bare, and the temperature, outdoor temperature, was 105 degrees, the air temperature. The soil temperature was 130, where it was bare. Anybody want to guess where the cover crop was growing, what the soil temperature was? 74 degrees. Air temperature of 105, and the soil temperature was 74 degrees. Now, that's just air temperature. Now, I'm sure nobody's heard about anything about climate change and all that kind of stuff, but this is one of the main causes. It's a soil problem. Just like most of the problems in the world, most of the problems in the world can be solved by two things: addressing the heart and addressing the character of the soil. You would fix almost every ill that society has. So you want to keep it covered. The moisture levels are higher. Microbes in the soil shut down. You go over about 80 degrees and they're shutting down. They're not functional. And so if they're not functional, the plant's not getting the benefit of those microbes in the process of growth. And in fact, if it's that hot, the plant is transpiring a whole lot more water, and it may actually have to shut down. You'll see when we get to well, I should probably just share some of this stuff as I go along in case we don't get to it. When a plant shuts down and it's no longer photosynthesizing because it's too hot, not enough moisture, it stops photosynthesizing, and so if it doesn't have a reserve of energy that it can tap into, it starts breaking itself down. It goes into photorespiration and starts breaking itself down. Has anybody had problems with spider mites, thrips? The plant's breaking proteins down to get energy, and it's leaving free ammonia in the plant tissue. And free ammonia in the plant tissue is, I don't know if there's some people old enough in here to remember neon signs. It's like putting a big bright neon sign up saying, the restaurant's open, come and eat. Because they're coming to get the ammonium nitrogen. They can't digest amino acids, they can't digest proteins. And so there's a way to address that, to prevent that from happening. I just wanted to throw that one in here to give you an illustration. You'll see how you eliminate diseases and insects from being a problem. And we're going to get to that here in just a minute. Okay, diversity. Tons of research on diversity here. I didn't put the pictures here. They're in another one. I just took a couple, 3 pictures of my high tunnel, about 30 minutes from here. And we'll talk about it more there. But the more diversity you have, the healthier everything becomes. And so, like for example, I'll show the picture if we get to it. We have pole beans in the center of our bed growing up bamboo poles. And they're angled out, going opposite sides. On the one side, beside it, we have half of the bed is spinach, a row of spinach. The other half is a row of beets. On the other side, we have the whole row is carrots. We have another bed that's got onions going down either side, and we have a shelling bean that goes down the middle of it. So we have all these different plants growing together. So you can still be productive. Keep hitting that thing, sorry. You can still be productive and grow crops food crops, but still have diversity there. And we don't have the time to go into the research that's involved with this, but I'll share this one illustration. This place in Germany that's doing research on this diversity, crop diversity and everything, they wound up getting flooded one year. And they figured everything died, but they had some plants out of the water and some plants in the water. And one of the interesting things happened in the places where they had plants out of the water and other plants underwater. Guess what was happening? The plants out of the water were helping the plants under the water. And so when the water receded, those plants were still alive and recovered. Does anybody see a principle here starting to build? We'll talk about the press down and overflowing condition later when we get to that. But the whole system is designed to give, but you have to receive to give. But the whole system is designed to give, and everything should have its food source. Okay. Minimal disturbance. Now, I have people ask me, there's a principle that's involved with that. The plow often and plow deep. People immediately assume it's got to be iron. But do you know you can till soil with plants? You can actually plow soil with chemistry. And so the principle is not abandoned. The question is, if you have to open that soil up because it's too hard, I don't think we'll get to it about the hardening of Pharaoh's heart, but if that soil is too hard and you've got to get air into it, you've got to get air exchange into it, you may have to till that soil. Is it the best option? Well, given the conditions, it is. But is it the best optimal option? No. But you don't have the conditions yet that you can avoid that. So, we'll get to all this as we go along. It's hard I want to deviate onto 3 or 4 different things that are going to come up in the future here, but we better keep moving or we'll never get through it. Okay, and I just alluded to this one a little bit. Know your context. What are you dealing with? Are you in western Kansas where you only get 12 inches of rain a year, and this year they didn't get any rain at all? They lost most of the wheat crop. They had the worst wheat crop in 57 years in Kansas this year. They lost almost all of it. This stuff happens, and if you're not in the field, you don't really notice it because it's not necessarily put out there on the news. The Georgia peach crop was totally lost this year because of weather. Totally. No peaches in Georgia. Could share a few more of those, but you got to keep going here. So how does the soil actually work to provide nourishment to growing plants? These are the ways that it happens. You have a colloidal exchange complex, clay, humus, and root. What do I mean by colloidal exchange complex? Colloidal just means it has a charge. So you know what I mean when I say a positive or a negative charge? The exchange complex largely has a negative charge. And as a result, any nutritional elements that have a positive charge, what do you think would happen? They'd be attracted, wouldn't they? Because opposites attract. What if any of those elements had a negative charge? They would be repelled. Now, there is some of that exchange complex you'll see that actually has a positive charge too, and is important. And that's part of the living complex, in the soil. Okay, so you have the colloidal exchange complex, which is part of the clay, the humus in the soil, and the root. They all have a charge on them. Then you have organic matter and humus storage. It's in the humus storage, which is just stable organic matter. That's anything that was once alive that's broken down to where it can't break down anymore. It's now humus. The humus actually has about 30 times more exchange capacity than the clay. And it has a way more positive exchange capacity on it. And then microbial action and interaction. So conventional agriculture thinks that you have to put soluble nutrients on so the plant can take them up as soluble nutrients. But you do not want nutritional elements in the soluble form. You want them, what Dr. William Albrecht always said, you want them insoluble but available. And this whole complex provides, if it's properly built, properly constructed, will provide available nutrition but insoluble. What happens to something that's soluble and a bunch of water runs through the soil? Goes with it. If it's properly stored, it doesn't go away. It stays there. The difference between photosynthetic production and biosynthetic production. Most of the food, like I said, that you get is produced based on photosynthetic production. Calories, because calories are what produce pounds and bushels and volume. And you'll see on the one side it produces carbonaceous bulk, primarily energy and calories, and it's driven by yield. What you want is biosynthetic production. In biosynthetic production, you're producing mineralized proteinaceous bulk. It's a complete food source, and it's quality driven. So you have to start focusing yourself on quality driven growing, not just on yield. A lot of people like to brag about, well, I produced 100 pounds of tomatoes off of my tomatoes. I think the record is 500 and something pounds off of one plant for tomatoes. Take a stab at what the yield is for potatoes off of one plant. Anybody want to guess? 50 pounds? I heard 50 pounds. 50. We got 55, 50. Any other guesses?
750 pounds.
How much?
750
750
pounds.
pounds. You're ambitious. The average, I'll give you this one, the average commercial yield is 2 pounds per plant. So you want to stick with 750? Or 50? Who said 100? It is 100 pounds off of one potato plant. Do you know that that plants are only photosynthesizing at best at 25% of their capacity? At best, only 25% of their capacity. And we're only reaching a small fraction of the yield potential of our crops. But we're expecting them to produce in soil and under conditions that are way less than desirable. And they're impossible for them to do that. By the way, the guy that hit that record with potatoes, he just quit because he told everybody what he was doing, and still nobody came even close to how he was producing it. So he just quit because he got bored with it. But we want to focus. You want to focus on biosynthetic production, not just producing calories. And so what you want to do is you want to feed the soil and let the soil feed the crop. Now this principle, I don't have a lot of it in here, but this is a spiritual principle too. Quite often we try to produce the crop by feeding it, but we don't ever bother to look at the character and correcting the character, and then letting the character bear that fruit. It will, if you sow the seed there. It will. So you want to focus on the soil, not the crop. Now, you might be working with conditions sometimes where the soil is just not in a great place. And so you might have to do some things to help the crop along. Remember I said that know your context thing and the principles there. You have to know where you are in the process. And so it's much better to get a crop than to not get anything at all, even if that means that you have to address some of the things that the crop may need that the soil's just not going to be able to deliver adequately yet. And there's ways of doing that. You can grow without fertilizers, but you can't grow without fertility. You know what I mean by that? Some people think that you just don't have to do anything and it'll just work. I'd be happy for them to show me how that works, because I don't know how that works. So you're in the mission field. You don't have access to all the stuff. I'm going to say this, but the truth is that we have the ability to deliver just about anything anywhere in the world now if we really wanted to. If we really believed it was important enough, we could make available whatever was necessary anywhere. But if you're in the mission field, you just don't have easy access to the things you need. You don't even know what the condition of your soil really is. Well, you can simply apply some principles like making sure that the soil can get air in it. If it's tight, you need to work it some, whether it's just digging it with a digging fork or whatever to loosen it up so that moisture and air. It's got to have water. You saw that slide where I showed the thing missing in that first slide I showed you on organic growth was water. That field was only a few miles from the Orange River in this western cape of South Africa. It was only a few miles from abundance of water. But without water, nothing was going to happen there. Did you have a question?
I do. We're in the hills of northern Georgia, and in some of our land we have good topsoil, probably where we clear trees and there were leaves born.
Uh-huh.
In other parts it's not that deep. So what I'm perplexed about is when you test the soil, and then under the topsoil there's that red clay soil. So when you test the soil, what are you testing? And how do you know that it's the same, say, over an acre? How do you know that the chemical composition is the same or mineral composition is the same?
Okay, so did everybody hear that question? He was basically...
Can you repeat it for the people online?
Yeah. He was asking, how do you know that the fertility is the same? Like he's in northern hills of Georgia, and you have some topsoil there, and then you have that red clay underneath there. Well, usually when I'm having somebody do that, this is a whole class in itself, but usually when I'm having there's some things you need to look at. What is the topography of the soil? What is the color of the soil, the texture of the soil, and everything? And when you take that sample, you'll sample down to a certain depth. And you're going to take into consideration whatever's at that depth. And with time, if you address that top few inches, well, it's about 6.5, 7 inches. If you address that, which is the aerobic zone of the soil typically, if you address that, it will actually start addressing it deeper and deeper and deeper. Now, people look at that red clay, and it's pretty weathered. But I've looked at some clays that had the chemistry straightened out of them. And in other words, when I say that, it just put that pore space into that soil. Now, clay is a lot finer material than sand. And we'll get to a slide about that in a little bit. But you can still open it up. And I picked up some soil in a field. It was growing grain sorghum. And I picked the soil up and felt it between my fingers. And it felt, I mean, you know what clay feels like in between your fingers. But that crop was growing a beautiful crop of sorghum. In fact, it was a record yield on that field. So it may not appear to us that it is, but if there are principles that are followed. But yeah, you have to, like, fertility runs downhill. So if you've got a field uphill and you've got a field downhill, the vast majority of the time, the lower field is going to be more fertile than the upper field. Unless you've been putting a bunch of stuff on you shouldn't have been putting on, and then that lower field is probably going to be a lot worse than the upper field because it all ran down into it. And this is the thing you need to know. You need to know, well, let me say it this way. You can't manage what you don't measure. And you want to have good information because I see this over and over and over. You want to have good information about what you're trying to do because with good information, you can make good decisions. And with good decisions, you generally have good outcomes. But when you're just guessing at something, I should use an illustration there. We need to take a break. Here, I work with a lot of blueberries. What is the one thing that comes to your mind if I say blueberries and fertility? Acidic. Nobody said anything different. You know, I've asked all kinds of people within the academic world and within the blueberry nursery world and everything, why you have to do that. And the answer commonly is just what you have to do. We have Amish neighbors. We live in an Amish community. And we like to ask them questions every once in a while. Like one of them was, you know, they all drive open buggies, but I've seen communities that all drive closed buggies. And some of them that have mixed and everything. So we just out of curiosity say, we just noticed everybody has open buggies. Is there a particular reason as opposed to, it's just what we do. So I won't belabor the illustration, but the truth is the best blueberries don't grow on acid soil. And the bottom line is they were discovered in the wild tolerating acid sandstone soils that were poor fertility. And they could tolerate it there because there were other conditions that were favorable, which was in particular was the moisture levels. But I had a guy in Western Kentucky who followed that acid regimen. And it all comes down to iron and manganese. There are other factors, but it comes down to iron and manganese relative to the acidity. And he had plenty of manganese. He didn't need it. He had plenty of iron. He didn't need to acidify his soil. But he did anyway, because that's what he was told to do. And then we had to straighten him out. I had to straighten him out because his blueberries were so toxic with toxic levels of manganese and aluminum that he couldn't sell them. This is why I'm trying to share with you principles that need to be followed. But you can narrow down. There's variability in soils. But you can narrow it down quite a bit. Now, if you go out, you've got 10,000 acre farms. They're doing what they call EC mapping, where they can get all the variability in the field in general to a certain extent. And then they'll go out and they'll do their soil testing based on that mapping. And then they have variable application trucks now that can adjust how much they're applying of different mineral elements as they're flying through the field to do that. They have the technology to do that. But in general, on a gardening level, anything just a few acres or something like that, there's some questions to ask and figure out, how do I need to take the sample, and it'll be pretty accurate. And if you get to a point, well, I have to share another illustration. I won't do too many of them because we'll take up all my time doing that. But another gardener out in Oregon, And his garden was fantastic. We looked at his soil test, and it was really good and everything. But one end of his garden wasn't doing very well. And so he said, well, why is that not doing well? I said, well, are you willing to test it separately? He said, yeah, I want to know why it's not doing very well when everything else is doing really well. And he had these little puny potatoes. He was growing one of the things he was growing was potatoes, and he had these little puny potatoes. And the other crops weren't doing really well. So when we got the soil test back, the reason that it wasn't doing well, he already had fairly high levels. They were still within a good range where it was okay, but he had high levels of potassium. And potassium at that level was tying up boron, and that was why he wasn't getting size on the potatoes, and he was having scab on the potatoes, and it was because between sodium and potassium, I'm sharing some of the principles of the soil test stuff, which you probably won't remember, but if they're more than 10% saturation between sodium and potassium, it'll block out manganese, and that's why he had the scab. And it all because that end of his garden was a little bit higher. It went over the threshold, and it was now tying stuff up and blocking stuff out, and that's why it wasn't doing well. So you can narrow it down as you improve an area, and you still see, well, this area is still not doing that well, and you can test it and say, okay, what's the difference? And you can figure it out on it. What was the question? Manganese is usually the reason that the potatoes get scab. A lot of people will tell you it's calcium when you apply limestone and everything. The reason they say that is because when you apply limestone, it raises the pH. And if you're borderline manganese and it goes over that threshold again, where it ties up enough manganese, the increased pH ties up enough manganese, that's what causes the scab. It's not the calcium, it's the effect of the calcium on manganese. Well, you have to raise, we had to bring the potassium down, which with sulfur. Unfortunately, we're not going to be able to do the whole soil class where we talk about testing and all the different stuff, but you can take it out with sulfur and leach it out. And you don't want to ever be above 7.5%, and it was at 11%. And so at 11%, it was tying up boron and it was blocking out manganese all by itself. It didn't even need the sodium to get to the 10% because it was 11%. So you got to bring it back down below that. And then in his case, his manganese was great. He had fantastic manganese levels. He didn't need manganese. He had really good boron levels, but the potassium was tying them up and blocking them out. And so if we fix that, then that problem will go away. Those two problems, which it did. I don't have the picture in here, but I'll share this one too, because I want you to see that there is actually a way that can be pursued where you can produce food as medicine. Highly nutritious, nutrient-dense food. I had another client in north central Nebraska, and they had some apricot trees. They were 6 years old. They never even bloomed. And so they were in 5B, so they were kind of right on the edge of how far north you could go with apricot trees. So it was either, well, you're just a little too far north to grow apricots. But when I looked at their soil test, it just stuck out. Your boron and copper levels are too low. So I said, if you're willing to give them, some forbearance for another year or two, let's see what happens by getting this chemistry straightened out. Well, that was last year. I got a picture this spring. Those apricot trees were all in bloom in their 7th year, and it was simply a chemistry issue. A lack of nutrients they were allowing that tree, because it was in a colder environment, and so it was going to take more for them to endure the cold weather and also set flowers, buds. But I've got that picture. I was going to put it on my slide thing, but I forgot to do it. But they sent me a picture of that. All thrilled. I need to check with them and see if they had a lot of cold late freezes too. So I don't know if they actually got any flowers to set fruit and are picking. They would be picking fruit here in a couple of weeks, probably. They did. Okay, we actually need to take a break. If it's okay with you guys, let's just take about a 10-minute break. So it's 4:30. Let's be back ready to go in about 10 minutes, 4:40.